on those legs. No. What are these? What? I don't know. Testing two. Whoa. Porcupines? Porcupines?
Oh,
It's a centipede. Look at all those
legs.
No. Oh, I got it. It's a phone. Hello?
Yeah.
Oh, it's a tooth. No. Oh, I got it. It's a phone. Yeah.
All right, we'll give everybody a minute to show up. How are we doing this afternoon?
Doing good, Dr. Dean.
All right.
Dr. Dean.
Yes, sir.
So, for a lot of our classes, the way it's looking, it's like a lot of us got to try to download Adobe. I don't know if we're going to have to do it for your class. I feel like we might. I feel like you said we're doing Cengage mostly, though, so maybe not. But for a lot of classes such as Dr. Driggins and Dr. Driggins and mostly it's Dr. Driggins right now.
Just Dr. Driggins.
Right. It's like we got to do Adobe, and it's trying to make us pay. So I'm hoping they won't make us try to do it with you.
I'm not. I mean, the only thing that you.
Because I know
you guys use it. We won't use Adobe like editor or anything. We might use Adobe Flash, but like Google Chrome and Safari and everything comes with Flash already in it, so you don't even have to download anything.
Because I don't know, maybe it's something. Maybe it's the way that she got it put on her biology thing, but it's giving me a headache. I've been sitting here trying to do this work all morning, and some of the other students, and we can't figure it out because we just can't do it. So I ain't wanted to run into a problem when it comes to doing your work or nothing.
Yeah, no, nothing. There's nothing that you need to download. For my class, the only thing that there are a couple things that I suggest maybe downloading.
As long as it's not $20 a month.
Is Zoom.
Got it.
And which is what we're using right now. But you don't have to. I think it's just better to use the app that you can download. But then there's also Discord for my office hours and that stuff, which that is also free. So there's definitely nothing that you should be paying for in my class. I cannot speak for Dr. Driggins.
All right. Well, if I do happen to run into the issue, like I just didn't want to, or if any of the students, I didn't want it to like come up and all of a sudden be like, "Oh snap," or like, "Oh, I didn't want you to feel like we fibbing or nothing." That's a nice way of saying lying.
Well, I assume you're fibbing, even when you say hello. I know you don't mean it. So.
Right, I must have drunk a little too much wine or something.
Yeah, that's what I heard. I heard you were enjoying yourself.
It got to be the wine. But no, seriously though, I don't know what's up with that class. It's just the documents or something. I'm just like, I don't know what to tell them.
She just wants us to pay for stuff.
Like I can barely afford it. I can barely afford the health insurance.
Not you broke.
Super broke. When it comes to having to pay for stuff I already paid for with the tuition, yeah, I'm broke. You ain't right, I'm broke.
They better take what they charging us for our lunch fees to pay for it.
That's what I'm saying.
They don't want to give.
Send me an access code for the Adobe Flash. I'd download all of it today.
Well, Adobe Flash is free. You've already got it. It's in.
Right, I should. But I don't know. Maybe it's just the way that she got us using it. I don't know. Maybe it's just the way that she got us using it. I don't know. I'm just not trying to get a 0. So I don't want to sound like no surprise. Cause I definitely going. I'm gonna explain to all my professors. Know some of my classes require Adobe on, or some form of Adobe, and I can't use it. So you believe that? Talking some $20 a month, Dr. Dean. I was like, oh.
Yeah, that's
I
pretty silly.
Right. I mean, like I feel like I heard one of the students say they better use that room and board that we're not using and pay for something. I don't know.
Yeah, I don't know how they're going to manage all that stuff. But yeah, you would hope that they would come up with some sort of easement plan, or you just never know.
Right.
So I think everybody who's coming should be in by now. So, all right. Okay. Welcome to my teaching dojo. I'm kind of taking over my class, my entire upstairs. So, so for those who weren't here last time, no, that's not the right page. Where is? All right. So we have added some things. Got some stuff in my way. So we have, last time we went over this document in e-learning, PHYS-312. And going online. One extra thing that we did add to that is, let's see if I can pull it up here. So I added a link to the YouTube channel.
Cool.
And sorry, I'm trying to pick it up. All right. So this is the channel, and basically what's going to be happening is I've got playlists for each class, and I'm just going to date and add each video to the different playlist. Probably add a brief description of like what chapter we went over or whatever for that one. But so that link takes you here, and you can yeah, you can go and check it out. Review anything that we went over. Happy to share those. So let's see. Also with this, was gonna kind of go back over what we had been discussing, which is magnetism. Chapter 19, and this was the one of the quiz that we did. So I'm pulling up my notes on my computer. All right, so let's see. So in this thing. So we've been talking about magnetic fields. We've been talking about where they come from, what they do, all of these little bits of information. And so I guess one question is, where do they come from? Yeah, I mean, I guess that's the only way I can ask that. Where do they come from? What causes a magnetic field?
Like moving charges?
Moving charges. Absolutely right. And
Or
what do we call a bunch of moving charges?
Electromagnets?
A
Is it
current.
current?
A current. Yeah, exactly right.
That boy is smart.
So
Trying to be like you, man.
this was the big difference between electric forces, which deal with just charge, and they only act on things with charge. But when we get to magnetism, suddenly it's all about moving charge. So moving charges create a magnetic field, and they're also the only thing that can experience a force from a magnetic field. So if you have a magnetic field just out in space, whatever, and you have charges in that field, they don't care. They'll just sit there. They won't do anything. They'll just sit in the magnetic field. They only experience a force when they start to move. And this is one of the things that we can see through, we have the equation up here. Hold on, so we can see this through our equation. Who remembers what the force from a magnetic field equation?
Cody,
You said what?
mute your microphone.
That's your breath.
It's not actually. It's your forehead kissing the phone.
Can y'all please stop? Dang.
All right. So what is the equation for a force from a magnetic field? That's definitely backwards.
See.
You said the force for a magnetic field.
Yeah. Force from a magnetic field.
Why y'all sound low?
Because I had to back up. Apparently, I was too close.
So there was two different versions of it. One was on a single charge, and one was on a current.
Is it E equals F over QS?
No.
Is it
it's
Q?
QS times V?
Is it QVB sine?
Yeah.
Yeah. So one of them is Q velocity cross.
Oh, I see the other one.
And the sine.
What was the other one?
Sine.
QSV times V. Right? No.
Is it QV cross B?
That's this one.
Never mind.
Oh yeah, that's the only one I got. Maybe I was tripping in class.
So we said that there's two different ways of thinking about this. About a single charge that's moving, and then about a bunch of charges that are moving. But what is a bunch of charges that are moving?
Current.
A current.
Also, you got to put I in somewhere. Right?
Yeah.
Like,
so that'd be
ILB.
I what?
Is it I times L times B?
Yeah, it's
Oh,
I
snap.
L cross B. So I is the current, L is the length of the wire that current is in, and B is the
Magnetic field.
magnetic field. So I know you guys hate equations and all that kind of stuff, but they contain a lot of information that doesn't always it's not always as simple as just plugging something into the equation, because these are relationships, and we can tell a lot about the physical nature just by the relationships. One of those things is what I was saying a second ago. Magnetic forces only happen when what?
A bunch of charges are moving.
If the charges are moving. Well, how can we tell that on these equations?
Well, with I, you can tell by how big or fast the current's moving, correct? Give or take a little bit of what I just said being wrong.
So how fast is kind of a weird thing to say about current.
Oh, well, what's the charge of the current, I guess?
You could make current bigger if the charges were going faster, or you can make it bigger if there were more of them. So if you had 10 charges going at 10 miles an hour, you could either double the number of charges or double their speed. Either one of those would make the current twice as much. So fast is kind of narrow about it, but we can take the current example.
Okay.
If the charges aren't moving, then what is the current?
It's zero.
Zero.
Yeah.
Even it doesn't matter how many charges there are, if the charges aren't moving, then there is no current. Well, if you plug a 0 in for right here, what do you get?
Zero.
0. Because 0 times anything is 0.
It automatically 0.
I think that needs to be on the test. I like that question.
It might be part of a question on the test. So maybe, kind of. But these are the kinds of things, like I said, I want to familiarize you guys with what these mean. So in order to experience a magnetic field, it has to have charge and it has to be moving. It has to have both of these things or nothing will happen. So that's what you could look at it on this one. If Q is 0, if there are no charges, it's not going to experience anything from the magnetic field. And if the velocity is 0, or if they're not moving, then it will also not experience anything from the magnetic field. Is there a way that there could be charges, and those charges are moving, but it still doesn't experience a force, so it doesn't interact with the magnetic field? Is there a way for that?
Maybe if they neutralize each other out, I guess.
No.
Dang it.
So you can get this information from the equations. But what is another way you can make, and this is something I maybe didn't play up as much as I should have, but if the force exists that means it's interacting with the magnetic field. If it experiences a force from the magnetic field, that means that they are interacting. So when I say what is required for there to be an interaction, I mean what has to be the case for this to not be zero? Or on the other side of that, what things could happen that would make this zero? And we already said that if Q is zero or V is zero, then you'll get zero. But purely mathematically, is there another way to make this zero?
Well, you already said if I is 0, then it's 0 too, right?
Yeah, but that's
What is B
actually the
again?
same thing as saying that Q is 0 or V is 0.
Oh, that's basically the same thing you said.
Yeah.
Okay.
So
Got
it's not about I or L
that.
being 0.
So are we looking at the
It is only B.
So what if the area is 0?
The area, what area? You might be right. I don't know what you mean by area.
Like in the other equation you gave us,
Oh, you're
it
talking about
mentioned
the
something
torque
about.
equation?
Say it again.
Are you talking about the torque equation? The
Yeah.
one with the funny looking thing?
Yeah.
Yeah. So that's a different set of equations that I'll refresh on in a little bit. But this is where this one kind of came from. So that's where we're starting back with this one. But what's another way to make this equal 0?
All right. So you said L and B basically go hand in hand with I, so I got to knock that out.
I will say that Q, V, B, I, L, none of those are 0.
Okay, so then you said, how can we get the force to equal 0, right? I mean,
if none of the numbers up here are 0, how could you make the force?
If it's a negative force acting upon that, I guess. Or like kind of going against it, I guess. Let's say like since it's a current, whatever would stop occurring, if it was the equal amount of whatever all the numbers are.
Well, but if you stop the current, then I is 0.
Right. So
Yeah.
then, yeah, and none of them are 0, right? That's tough. I'm thinking. Ain't no way in the world this question that hard. It's probably something simple. Watch. You're gonna say something like gravity.
Probably is.
You're gonna say something like gravity equals 1.2.
It's a purely mathematical thing.
See,
Like, what
that's
if,
where
like,
you
what
lost
if
me
all
right
the
there.
numbers?
So area and what else? What's another hint?
So area is kind of a funny hint, but
Like the surface, the radius, the diameter.
Area is length times width times mass. Length times width or height.
if we're talking about the magnitude,
Also, if the magnitude is
Pi.
Pi.
Oh no, I'm just saying stuff now. Sine theta.
so when you're talking about the magnitude of a cross product, which is what these are, you get this equation. So we already said that Q, V, and B, none of these are 0. So whatever this is, it is a number.
Mhm.
So the other way you can make this 0 is if this is 0.
Oh, so sine theta is 0 pretty much, basically.
So what has to be true for sine theta to equal 0?
What has to be true? Well, so I know what QS, V, and B is, but Probably because I don't know what sign that is. I can't answer it. Somebody else might know what that means. If that's the case, take it away, people.
If they knew their answer.
Right.
Exactly.
Sorry, I'm working on something else while you guys are thinking.
Theta has to be 0, right?
Well, no, he
Theta-
said what what
Theta
is
can be 0. Great answer. So, sine theta equals 0 means theta is 0. But what else could theta be?
2 pi, I guess.
That's the same as 0.
Oh, true.
I guess it can be negative whatever
It could be pi.
the rest. You said it can be 1.
Very good. So if sine theta equals 0, that means theta equals 0 or pi. But what does theta have to do with the equation? Like what does theta mean?
Angle?
It's an angle. What angle?
Direction, I guess.
Not quite direction. It is really an angle.
I'm talking about like 0 and 180.
But what is an angle?
What is that?
We're getting real real old school with this one.
See, look, I'm not gonna act like I'm the best one at math.
What is an angle?
An angle is a number that you get when you put like 2 lines together and like kind of like a V shape.
An angle is distance. 45, 90. 180, 360.
Yeah, I guess it's
By
kind of like
degrees.
So, Master, what is it? Poppy Watto? Is that
Poppy
In the
water.
flesh, in the flesh.
Bye, Cody.
angle is a kind
Measurement
of
between
distance,
2 lines. Yeah.
but it has to do with the separation between 2 lines,
Let me
or
find
in
out.
our case, vectors. So
Okay.
let's say this one is V, and
Let me find out. I was on to something that was high.
so theta is the angle between V, the direction of V, and the direction of B. If that angle is 0, what does it mean about those 2 arrows? What
Lines.
in God's name?
Distance.
Hold on, one more time. Then somebody watching something in the background. I can't
Yeah.
hear you.
I
I don't know. They watch Dragon Ball
I didn't hear any of
Z.
that.
What was
What does
that?
it mean?
Okay.
They over there tripping.
What does it mean if that angle is 0?
Then B
so
and
the
V is
angle
the
between
same.
2 vectors are 0.
B and
Yeah,
V is the same.
Then the 2 vectors are in the same direction. What does it
All right.
mean if the angle is pi?
Then it's 3.14.
Then they in the opposite direction.
Then they're in the opposite direction. Perfect.
Ah.
So the other way that you can make this force be 0, or to state it a little bit differently, you can have moving charges inside a field. If those 2 are going in the same direction or in opposite directions, then they won't interact.
So I should probably write that down beside it.
So
So you said, so if the vectors
when theta
are
equals 0,
the
V
vectors
and B are in the same direction.
same direction.
When
So they're parallel.
Mm-hmm.
Yeah, so you can say they are parallel. When theta equals pi or 180 degrees.
Just like in a unit circle.
Then the two are in opposite directions.
Oh.
And does anybody know what this is called? When two vectors are in opposite directions?
Perpendicular?
No, perpendicular means
Kind of like an X.
they do that.
Yeah.
But
Or
what letter it
plus
start
sign.
with? What letter it start with?
Ocean.
Starts with A, and it's actually a hyphenated word.
Hyphenated. Lord, I can't even spell hyphen.
Siri, look up words that start with A.
Hold on, hold
But,
on.
is
Hold on,
it
hold
is it
on.
angular?
What did you
Angular?
call these?
Okay, I found this on the web.
What?
Somebody.
Hold on,
That
man.
boy cheating,
What
man.
Hold on, man.
Swoo, what did you call these?
You call them parallel.
Parallel.
Yeah.
So
There are two
Is it
two
like
lines are
A,
same
B
in the
something?
same direction.
So when two lines have the same slope,
Yeah.
they are parallel.
Right.
Lines don't
Exactly.
really have directions, but vectors can have the same slope, but be in the opposite direction. These two are called anti-parallel.
I'm dead.
Anti-parallel.
Wow.
Ain't no way it was that easy.
It
Exactly.
was.
I'm sitting here thinking rocket science about to blow my brain.
Talking about rocket science.
Right.
And because one line's going to this direction and the other one goes to another one.
Yeah. So, but they're still, if they were just looking at the lines part of them, they still look like parallel lines if we didn't know what direction they were. But fun fact, and that way, if you guys ever see this stuff with, I don't know, Dr. Lane or
Oh,
Boozer,
yeah.
in higher math class, you guys can be like, oh,
Oh,
there's an
yeah.
anti-parallel.
Yeah.
Dr. Lane, I'm sorry.
Like in geometry.
Yeah. So,
So,
but this is
Cody.
we're just trying to get back to where we were, trying to see, what all do we know and what can we
ooh,
where is my
I'm about to cry.
mouse? We're trying to see what kind of things do we need to be paying attention to. This gets kind of lost because people see an equation and they're like, oh, I just need to plug stuff in and be done with it. It's a relationship, and we put it in mathematical terms because there's lots of stuff that we can pull out of a very simple, quick little equation that it would take a lot to write out. But if we put it in equation form, then we can ask questions about it. Well, what if Q is 0? Well, then the force is 0. What if V is 0?
So everything's going to be 0.
No, it's not always going to be 0. But the idea is you can say, well, if we make Q bigger, if we add more charge, what happens? Well, then the force goes up. We make V bigger or B. So you can ask questions like that. What if we change a variable? What happens to the system? So this is, where'd my mouse go? Sorry, I've kind of taken over my upstairs loft, and it's a little bit ridiculous.
It happens.
So,
pretty sure my room looks the same.
One of the other things that we started talking about was torque from last time.
Oh, God. All these big words.
And so this is what we were talking about. We took that second equation that we had, which was IL cross B, and we applied it to this example. And we found that if you have a loop of current going around, on the left, you can see the black is basically a wire,
Mm-hmm.
and it's traveling, or it's taking current around that's clockwise. So, and it's in a field that is pointed to the right. What we found was, with our right-hand rule, that the left side, or the one with the 1 next to it, experiences a force into the board. So here, the force is pushing this part of the wire into the slide. We found that up here, what is the force on this one? So this is the current direction, and this is the magnetic field.
Right.
So what is the force?
So you said, ooh, Lord.
Okay.
What's the force?
No force.
There is no force. Why is there
There's no force at all.
See, y'all childish.
You can't go in the same direction.
Exactly, because
They're
B
going different ways.
is in the direction of I, so I cross B is 0.
Lord Jesus.
And then down here, the current is going down. So we found that these two experience a force. The little circle with a dot means that it's coming towards us. And then for the same reason as number 2, down here, this thing, this side does not experience a force because the current is anti-parallel to the field. Well, if you push this side down and this side up, it's going to spin. And as it spins, side 3 and 1 flip. So now 3 is on this side and 1 is on this side. But because the current changed direction, if we do the forces over here again, the force here pushes against, or pushes towards us, and the force here pushes into the board, which would then cause it to flip back to this. So it doesn't actually spin, it will go back and forth, back and forth. And we'll probably get cut off here in the next minute or so, but this back and forth twisting is actually how electric motors work.
So kind of like in the Tesla cars.
So Tesla coil is a little different. It's about creating very high, a Tesla car?
Yeah.
Okay, yeah. Yes. For the most part, most electric motors are based on this idea. These are a lot closer to how like mechanical electric toothbrushes work, but because they go back and forth, they don't spin all the way around. But this is the equation that governs how that happens. So before we get cut off, this is where we're going to be picking up on Friday, finishing up with this torque thing, and then then we'll be back to normal. So you guys have a fabulous rest of your day, and if you got any questions, email me, get on Discord, let me know, okay?
Homework. Yeah, I'll be on there.
All right, Dr. Dean.
All right, y'all take it easy.
Yeah, we still got homework. It ain't over because school closed.
Yep, sorry.
Could have never thought.
Okay.
Yes, sir.